Now, the charge on this, let it be Q1, Q2. Two thin concentric conducting shells. A and B are given charges Q1 and Q2. So find the energy of the system. Now what to do here? The interaction potential energy and also self energy. Self energy, as usual, again, this should become equal to self energy plus interaction potential. What is the self energy? Self energy of individual shell. So K Q1 square by 2A. K Q2 square by 2B. What about interaction potential G? K Q1 Q2 by B. Why not B minus A? Why this is specifically written like this? But actually, what is separation? B minus A, no? Okay, come for Gauss law. If you draw a Gaussian surface here, where do this whole charge Q1 will appear? It will appear to be concentrated at the center. Then what is the interaction? K Q1 Q2 by B. Am I right? Try to notice this denominator, not B minus A. For the outer shell, where do this whole charge Q1 will appear? It will appear at center. Though separation, physical separation is B minus C, the electrical separation will be equal to B. Able to understand this? Sir, if this is a negative, if it's a negative, what you're going to do? Let me make this one negative one. Then we'll see any changes will come. No, this I'm going to make it negative. I've given charges minus Q1 plus Q2. No, to construct a positively charged system or negatively charged system, I have to do mechanical work. Am I right? See, anything, either to construct a charged, negative charged body or positive charged body, X-ray agent has to do mechanical work. So minus of Q1 whole square, what you get? Let it be. Interaction potential, you know, it should be K. So this equation will end up like this. Got the idea? No, like slowly we'll go for what is the self energy of a point charge? Anybody wants to answer? Because I'm asking since you know very good maths. It is something mass related question. What is self energy of a point charge? Somebody should answer. Yeah, I'm waiting for answers. Anybody? Infinite? Neha, is it infinite? Okay, one answer. Anybody still? Gayatri, infinite. Now, from boys, anybody? Sushant, what is a self-energy of point charge? Sushant, are you there?
Yes, sir.
Okay, what is self-energy of point charge? Yeah. Point charge, what do you mean by point? Which will not have any volume, no? So no question of constructing it. So what is the self-energy of point charge? Zero, no? Geometry based question it is. Geometry based. You have to say point, how you define in corner geometry point, which will not have any volume, no? How you define point? Zero volume. So charge means zero volume means, oh no, there's nothing called okay. But in books, what happens? Self-energy of point charge, they just write like this, some UP. Some books they are given, if even if you take the SEORMA, he has written like self-energy of point charge. Will be negligible, better say. Huh? No, at least not infinite. Huh? Okay, no problem. No. So if I bring a point charge, so now what is the self-energy? Why I'm asked this question is, I have 3 point charges, Q1 minus Q2 plus Q3, separated by distance A, B, C. What is the energy of this system? No self-energy will come, only interaction potential will be there. Self-energy of 1s, 2s, 3s, plus interaction. Then afterwards, I'll write it here. 1s, 2s, 3s, plus interaction 1, 2, 1, 3, plus 2, 3. 1s will be 0, 2s will be 0, 3s will be 0. 1, 2, what is the interaction potential between 1, 2? It will be minus K, Q1, Q2, B. Between 1, 3, K, Q1, Q3, C. Q2, Q3, A. Interaction potential with the self-energy, because what is the self-energy of point charge is negligible. I'll write that statement somewhere here. It's negligible, better write it. Now you see the what